Very good morning to all. Few participants have joined us for this webinar. I'm just waiting few more to join us, and then we'll be starting with our session. Till then, I can see. Uh, Dr. Amit Gupta. Amit sir, if you can hear me.
Hello.
Very good morning, sir. I was just to test about that if I am audible fine.
Yeah, ma'am, you're quite audible, ma'am. If you can request Dr. Mr. Saurabh, he can
Ye-
share his screen.
yeah, sure, definitely, sir.
Hello there. Can you guys hear
Uh,
me?
Hi, Saurabh. This is Deepika Arora.
Hi, Deepika.
How are you?
Good, good. How are you?
We are doing good. So Shreyas has also joined us.
Yes.
Okay. Hi, Shreyas.
Hi.
Hi. We'll be starting in another 5 to 7 minutes. And Saurabh, I was to confirm that you will be sharing your screen for the presentation.
Sure. I will do
Yeah,
that.
yeah. That's
Are you able to see my screen?
yeah, Saurabh. That's perfect.
Awesome.
So, Saurabh, how's the under this COVID-19? How's the situation there?
Yeah, the that's a good question. We have been given rules by the county that we have to stay in place. That means you have to be in your house most of the time, and you go to get your groceries once in a while, or you do some online shopping, and stuff comes to your home, but mostly it's indoors.
Okay.
And it's hard for the schools because you can only do so much in the from a school's perspective. And I actually appreciate Gita Engineering College doing this kind of a seminar in this time, and be able to do this session remotely for the students. It's a very, very good initiative.
Yeah, actually, in this situation of COVID-19, many of the webinars have been presented, organized by the college. And this one today we have brought up with artificial intelligence and machine learning. Uh,
Right. Right. Yeah. So I think, yeah, I think it's a very good initiative because when the students cannot meet the teachers in person, how do you build a connection? I feel that you guys are, doing an awesome job and able to build that connection, build that community, and really, really think about, from a student's perspective. And that's what I really like about Gita Engineering College.
Well, thank you so much for appreciating our efforts. Sort of then we can start in another 5 to 7 minutes because a few of the participants are still in the waiting room. I'm just
Okay.
letting them in.
Okay, sounds good. Deepika, there is an option in Zoom as you as the host. Some people can do annotation on the, on the slide. So I think you can turn that off.
Okay. I'll see to it, sort of.
Okay, thanks.
I request the participants to kindly mute themselves so that we can very well start with the session. बेटा कार्डबोर्ड रख ले, इस बेडशीट पे चल जाएगा स्केच पेन, अगर चल गया ना देख लियो। A very good morning to all. I would like to request all the participants to kindly mute their mics so that we can start with the presentation. Well, a very good morning to all. I guess number of participants have already joined us. So can we start with the session, Amit sir, with your approval?
Sure, ma'am, we can start.
So, very good morning to all. Respected Director Sir, Dr. Saurabh Gupta, we have with us Dean of R&D Research and Development Department, Dr. Amit Gupta, Mr. Shreyas, who is an enthusiast in machine learning and artificial intelligence from California, and Mr. Saurabh Jan, Program Manager, F5 Networks, California. A very special guest from California and our speaker for today. Dear colleagues and my dear participants, I welcome you all at this webinar, a webinar on demystifying data science, artificial intelligence, and machine learning. I hope many of you must have come across terms like data science, machine learning, artificial intelligence, or deep learning. In 2020, people benefit from artificial intelligence every day, whether it's music recommendations, recommender systems, Google Maps, Uber, and many more applications are powered with AI. However, the confusion between the terms artificial intelligence, machine learning, and deep learning remains. But today, with our speaker, we'll be clearing our doubts about this confusion between the terms. So, before we start, I would like to tell the webinar has been organized and brought to you by Geeta Group of Institutions, Panipat. Geeta Group of Institutions is the prestigious education place in North India and is the most preferred education institute in the region. It has the best engineering campus, the best law college in Haryana and Delhi NCR, and number one ranked hotel management college. We also have Pharmacy College in the region. It provides with more than 50 programs in diploma, undergraduate, and postgraduate in engineering, law, management, hotel management, and other education courses. Few of them I would like to specify. We have with us diploma in software engineering, civil engineering, mechanical engineering. We have with us BTech in computer science engineering, civil engineering, electronics and communication, and mechanicals. We have diploma in pharmacy and bachelor in pharmacy with us. We also have few vocational courses like bachelor in vocation in interior engineering. We also have master courses, masters in technology in computer science, electronics and communication, mechanical and transportation engineering. We do have management courses, hotel management, and the law courses. The institute has more than 600 well qualified, dedicated, and distinguished faculty members, over 7,000 students who are from 10 different countries and 20 different states and union territories. So, here I thank the management of Geeta Group of Institutions, Panipat, to organize this webinar, and I believe it is going to be highly beneficial for the participants. Today, I have a pleasant duty of introducing our guest and speaker for today, Mr. Saurabh Jain. Mr. Saurabh Jain is an executive at Shape Security, which is a part of F5 Networks. He is a seasoned technologist with career spanning more than 20 years in the top tech companies in the world, like Amazon Web Services and Microsoft. Impacted a wide variety of products. If you use a computer or Windows, you are likely using some of the services Saurabh helped build. He has contributed to building database SQL Server in the US. His services are used by the major banks, mobile companies, retailers, and even a coffee house. He has been helping organization make the strategic decision. So here I extend my warm welcome to Mr. Saurabh Jain and Shreyas. We are grateful to you guys for providing this opportunity to interact with the participants. I, on the behalf of Institute, thank you for accepting the invitation to serve as the speaker at this webinar. I believe this is going to be very much beneficial for the participants. To start with, uh, before I start with our speaker, I would like to request all the participants that, dear participants, if you have any queries, if you have anything to say during the presentation, please type them into the chat box in your Zoom control panel. I will bring them up during the presentation to our speakers, and your queries could be resolved at the end. Also, to view the screen of the speaker, you can click on the screen and can have the maximized view of the speaker. So without further ado, I would like to now turn over time. I would like to turn the time over to Mr. Saurabh Jain to share his expert opinions about the latest trends in the computer science, AI, machine learning, data science. So, Mr. Saurabh, can we have you?
Sure. Can you see my screen now?
Yes, it's fine.
Awesome. So thank you, Deepika, first of all, for the very nice and generous and kind words. I'd like to take a minute before I get started to thank Sri Ankush ji. I have found him to be very, very forward thinking as the vice chairman of the Gita group of institutions, to be forward thinking in thinking about what the new future trend is. And it's really, you don't find this of, talks happening in even the more, well-known engineering colleges of India. So I would like to first of all acknowledge Sri Ankush ji and also thank Mr. Amit Gupta ji and Saurabh Gupta ji for being part of this and giving me and Shreyas Chen the opportunity to talk about data science, AI, and ML. So the today's agenda, Deepika has already given an introduction, so we'll be skimming through that quickly, but we'll mostly focus on AI, ML, data science, and talk in practical terms where this is being used to, if we can leave you a bit excited about what the future is offering in this area of science, we feel we would have accomplished our task. So some of the areas that we will dive into is cybersecurity. And some of you may have known about some kind of hacks and things happening on the internet as internet and becomes more and more mainstream. Then we'll talk about what's the science and art involved, and then Shreyas will talk about what it takes to build self-driving car. Self-driving cars will become a reality. We already are seeing some of that in action here in the US. And then finally, we'll talk about how AI is really impacting and coming up with a cure for COVID-19, which is affected worldwide. So that's where I will get into. Deepika talked about my my background, so I'm not going to spend too much time onto this. But what I found is that this is one of the most exciting times in the industry to come in and learn AI, machine learning, data science, and really think about taking what was typical software engineering to that really next level. It is quantum jumps for mankind. So here is the first example. So I'm going to be sharing with you some trade secrets today. So I would like that you have a very, very close ear and attention, because some of these concepts, some of these hacks that I will be talking to you about, you'll have to keep a very close watch and hear me very clearly about what I'm talking about here. So you might have seen that this is one of the recent news happened. Hackers turn Europe's supercomputers into cryptocurrency mining rigs. So some of you may have heard about Bitcoin mining. I don't know if you have heard, but Bitcoin mining is a virtual currency. It is becoming more and more popular. To do Bitcoin mining, what you need is, applying math algorithms over on a computer which does this processing called mining. Now, to do that mining, it requires lots and lots of, if you want to do mining in a serious way, you need to do using lots of computers. So here is what you must have heard of: cloud providers. You might have heard of Google Cloud, Amazon Web Service, Azure, Alibaba, IBM Cloud. So what happens is, I, as the bad guy, I come in, and what I will do is, I will I will not take any cash. I will not take any money, or I will not steal your utensils or your TVs. I will just steal your computer time. So if I can come into, for instance, Amazon Web Services and steal 1,000 computers 1 hour time, I can do lots and lots of Bitcoin mining. And again, how do you do that? You come up with some concepts of creating fake accounts, coming in, using the services for a little while. For instance, unlike when you shop at Flipkart or Amazon, where you pay initially or when the good comes at your door, here what happens is you use the service for X amount of time, and then you can abscond. So you can use the service for 20 days, and then you are gone, you're not visible. So these are some hooks, these are some techniques that fraudsters use. So this is not like a small boy or a girl doing this kind of a thing sitting in their garage. This is sophisticated science, and we need sophisticated engineers, sophisticated scientists, sophisticated artificial ML learning enthusiasts to counter such attacks. So I hope that gave you a sense of how hackers come in, they steal the computer time from these cloud providers, and they can steal it over for 2-3 days. They steal it, let's say, for even few hours. They end up doing a lot of Bitcoin mining. Another popular, and maybe not people may aware of, is an example of web scraping. So what this means is that, let's say I have a hotel, and my friend has a hotel down the street. Now I am the bad guy. What I do is, my competitor's hotel have pretty much similar rooms, have pretty much similar facilities, but I am the bad guy, the bad hotelier. What I will do is, whatever price the competitor is offering down the street, my price of the hotel will be 500 rupees or 200 rupees less than the competitors. And obviously, I'm not going to be sitting 24/7 changing and looking at my competitors' pricing. So what I will do is this: I will write a program called web scraping. What it will do is, it will go to my competitor's website, web scrape. So that means take out their pricings, get me those pricings, go through the entire website, find all the prices, and then I will just offer prices. The competitor price minus 300 rupees. So this is one example of how people use web scraping. There are even examples of airlines who have to outbid, they want to fight for getting the first customers, and how do I get the best pricing, if you will. So this is an example of even some things you may not be aware typically, that only bad sort of things do this, but it's actually even businesses are using this kind of knowledge to become. So it's being used for marketing, it's used for e-commerce, it's used for job boards, into finance, into data journalism. A lot of areas look at in the cybersecurity area are getting affected by web scraping. And it's a difficult thing to stop, because it's not like a fraudster, who is stealing something. This is a program that is coming in and just getting your rates. So how do you identify the good versus the bad? You cannot just bring it on your website. You cannot, you want to make sure that your legitimate customers who are genuinely coming in and wanting to stay in your hotel, for instance, have a good experience logging in, coming in and hitting the rates, or if you're a retailer coming in and finding the pricing of your item, if you will. So that's where the AI machine learning comes into picture, to be able to detect what is good traffic. What we call traffic means network traffic, login requests coming in. How do you differentiate between the good versus the bad? And the last challenge on top of that is you have to do it in real time. For instance, if you're trying to go to a hotel and the hourglass keeps spinning for 3 minutes to figure out if you are good or bad, you'll say, forget it. Let me go to some other hotel, right? So the idea, you have to do this in real time, in very, very fast fashion, if you will. So I hope this gives you a good example of some of the challenges with web scraping and what's happening in the industry as a whole. Another big example, which is, I tell this to my parents and also to friends and relatives. This is a very, very big phenomena that is happening because of all of us reusing username and passwords. So I have been guilty of that until I knew this, but all of us reuse the same username and passwords across multiple websites. So guess what? If you have an account with Flipkart and you have an account with, let's say, a bank, some bank, State Bank X, if the Flipkart data gets leaked, and it happens all the time, you keep reading about it, like million records, username, passwords, login credentials got leaked. Guess what? Fraudster has a merry day at that time. All they have to do is write a small program. They have this huge repository of 10 lakh, let's say, username and passwords. Even if 10%, 5%, or 1% of people have used the same username and password, what they will do is write a small program which reads this data, the stolen data, and keeps trying on another website. So if your Flipkart username and password is the same for the other bank, State Bank, it will probably go through now. That program will say, oh, username and password is the same. So that's the program that they write. So a leak in Flipkart had nothing to do with the bank, if you will. But now, because you use the same username and password, your account is now compromised at the bank. And there is where the signs become even more sophisticated. Even sometimes not only the username and password, just password alone, the fraudsters can figure out that you are so and so here in Flipkart, and you are the same person in the in this particular State Bank, so they can log in or hack into your account. So this is what I mean by credential stuffing. The attacker sends a whole bunch of credentials. 95% of them fail for XYZ reason, or people have used a different username and password. But even if 5% or 1% are reusing passwords between sites, then it's a great day for this guy, the attacker here. So I hope you're getting excited with all these different permutation combinations of things. And I can keep talking about this for hours, but almost every area that we look into is getting attacked in some nefarious manner, something that is not as evident to the common person. Right? And so, lots of attacks happening on your account takeover, where your account is taken over. They come in and start, doing nefarious things. Again, you have to differentiate between the good and the bad. There is, again, science involved that. Again, we'll talk about that in the next, few slides. But just be aware that this is a big shift as humans become more and more dependent on the internet, dependent on everything that our lives become more and more online. We have to do the right things in protecting, our accounts. Like we have taken care of, physical security, we have to take even more care of our online security. So, as I said, this is not a single event. This is generally, there are lots of things involved. It's not like, some things they will do at the, they might infest your computer with a malware, or steal your credential, or they may buy. You may be surprised that when leaks happen, they are sold on what's called the dark web, a web that is not as easily accessible, where they are sold for a price. Your username and password could be sold for pennies, on the dark web for fraudsters to go try out. And so, a whole bunch of steps in monitoring this from end to end is what happens in this fraud journey, if you will. So yeah, so again, you might be seeing requests to log in, enter your username, password. So you got to make sure that you're following healthy practices, looking at that it has an HTTPS, for instance, making sure that there are no even small typos in the spelling mistakes, because if you enter your login password in something somewhere else, then you're probably going to go to another site's data temporarily, where they will steal your username, password, and then go bring you back to the legitimate site. So there are lots of phishing scams, generally sent over emails, making look that they are very, very legitimate. So I'll pause at that for today. There's a lot more to talk about. My daughter calls me, maybe you are the James Bond, or this guy who's fighting this bad guys day in and day out, but it's not like that. Actually, this is the next topic that we talk about, is like, how do you counter this kind of sophistication, right? And the art here is big data. The big data or data science aspect to is leveraging lots and lots of data and figuring out what's good versus the bad. For instance, if I feed the computer 1 million images of a dog, then the next time I bring in the 1,000,001th dog, the computer will likely know that this is an image of a dog, right? So that's where the science comes. That's where there is amount of a little bit of a math involved in this, or statistics, coupled with overall engineering that brings this together. So the big data, the data science, the artificial intelligence is part of that whole equation to bring collecting the data and then applying your math, your science on it to really build that intelligence on top of it. And then analytics is the decision making, like what you do with it. Sometimes, the dog's picture may not be very clear, or it may be in low light. How do you make sure that it's good versus the bad, if you will? So, and then finally, as I said, it's never like a one person does it all. It's generally a teamwork. It requires good communication skills. And it's not like, hey, here is one cookie cutter example, just go do this and you will solve the problem. So what happens is, like, as you guys think about your, future careers, if you will, the answers to this is not like written in a textbook. But when you have a good sort of engineering or science background, then your foundation is solid, that you can go and solve these kind of problems. So that's my short summary, and we can take up questions at the end of the session, if you will. So I'll turn this over to Shreyas, who will give you some more examples about machine learning, and how where all machine learning and artificial intelligence is being leveraged. Go ahead, Shreyas.
So, hey guys, my name is Shreyas Jain, as many of you probably already know, and today I'm going to be talking to you guys about machine learning. Just before I start, I'd like to give some backstory about myself. I live in the state of California, and I'm a current 11th grader. I go to a school called Cupertino High School. So let's get right into this. Before I start, I'd like to share 2 quotes with you that I find very impactful. The first quote being by Mr. William Arthur Ward. He states, "If you can imagine it, you can achieve it. If you can dream it, you can become it." In this quote, Mr. Ward is stating how you must have dreams and ambitions. With these dreams and ambitions, You can keep pushing yourself further and further to cross even your own limits. Now, another quote, which is almost similar to this quote, is by Mr. Alexander Calder. He states, if you can imagine a thing, conjure it up in space, then you can make it. The universe is real, but you can't see it. You have to imagine it. Then you can be realistic about reproducing it. This quote is very similar to this previous quote. Mr. Calder is also stating that you must have dreams and ambitions to be able to succeed. And with these dreams and ambitions, then you can start thinking about how you want to go about solving these dreams. So with that, these are just two basic quotes I would like to share with you. Let's start getting into the machine learning for today. So how do we see machine learning in use today? Voice recognition. Voice recognition is very popular. You have Alexa by Amazon or Siri by Apple. These two things would not be able to run without machine learning, and I'll go into detail later. You also have cybersecurity, like my father talked about. So pretty much that's that. You also have driverless cars. That is what I'm going to be going into detail today. You have driverless cars. Those would not be able to function without machine learning. Same with search engines and the new COVID-19 situation or the coronavirus. That is also similar to tailored advertisements and many, many more. Today, I'm going to focus on the driverless cars and the COVID-19 situation.
I just removed the annotation once. Just switching the annotation once because there was a.
So, machine learning requires data, and without data, machine learning would not be possible. So, one big important one is your linear data. In this first example on the left, there's a linear relationship between the rainfall or how much it has rained compared to the number of umbrellas sold. That is a straight, complete linear relationship. As the rainfall increases, the number of umbrellas sold also increases. Now, the example on the right, you have the number of experience in years in a job. And as that increases, the salary of that person also increases. Now, this is not a straight line, meaning this is not a linear relationship. Now, there are three main types of regression in these models. You have simple linear regression, multiple linear regression, and polynomial linear regression. In simple linear regression, you have your basic equation, which is the y equals mx plus b equation. It is written like y equals b0 plus b1 x1 here, but it is your standard y equals mx plus b algebraic equation. You also have your multiple linear regression equation. This equation adds an extra variable to the mix, and this can add as many variables as we would like. Similar to this is the polynomial linear regression. In this equation, there is a variable to a certain power, like x to the third power, and this can be as many as you want. These are the three basic types of regression, and there are many, many more, but these are the three main ones that you should know. So now how does this all come together? There are going to be two life cycles I want to talk to you guys about that are used very popular in machine learning. You have your labeled data. With your labeled data, this is all the data you have collected so far. Once you've collected all this data, you can basically build a predictive model out of this data. And then with this predictive model, you can create new data, which the predictive model will make for you. And this is a complete cycle, which goes from labeled data to model to new data, and then back to labeled data and continuous. Here is another life cycle. This one starts with you reviewing your data. all the data you collected, you review it. Then once you review the data, you refine it, which means making it better so that you can put this data into the prototype model. And then with this prototype model, it will come out with new data, which you can review. And then it's the same process: review, refine, prototype, and continually. So there are multiple different categories in machine learning. Mainly, there are two main categories. You have supervised learning and unsupervised learning. In supervised learning, there are two subcategories. You have classification and regression. And in supervised learning, you're using the model, but you have both the input and the output data. So you already have the output data in a way. With the unsupervised learning, you are using clustering. In clustering, you use only the input data, so you have no output data to base this on. And with the clustering, you're basically grouping every single part of your data. These are the main groups in machine learning, but there are many more groups. These are the basic groups that everyone should know. So let's get started on the driverless cars section. So this is what our future would look like in driverless cars. As you can see, the car doors are opening in a different way than usual. The seats are facing each other rather than two seats facing forward and two seats behind facing forward again. There's no steering wheel. That means the AI will be doing all the driving. Now, the AI is programmed by the machine learning, and without machine learning, there would be no way that this would be possible. But this is the future. So let's look at how we can get to this state. I'm going to show you 3 different models of self-driving cars in the past. Firstly, you have this car. As you can see, there are many different things attached to this car for this car to be able to self-drive. Now, these parts I'll go over later in the next few slides. But as you can see, there's a very different thing attached on the roof of the car and different things attached throughout the body of the car. Here's another example of a different self-driving car. As you can see, inside of the car, you have a machine, a complete computer itself, a very huge computer just sitting in the trunk of the car. This is where all the information will be stored so the car can be able to self-drive. Here's a much different model. Instead of having a larger computer, you have a much smaller computer, which seems to be connected inside the laptop. Now, these are all just models, but how did we get to this position, or how can we get to this position? There's obviously cars like Tesla, but not everyone is at that state yet. So how did Tesla come about this? It started with the active cruise control. So the active cruise control is basically where you can take your foot off the gas and this car will go in a certain speed for that duration. There's also lane departure warning systems. Once you start going into another lane of another car, the car will automatically do a beeping noise, letting you know that you're swerving into another lane. Another one is the AEBS, or the Autonomous Emergency Braking System. This occurs when a car is at a very high speed and is about to crash into another car, and the car will automatically brake by itself. This is also similar to the FCMS, or the Forward Collision Mitigation Systems. These are all basic functions of a self-driving car, and with these basic functions, you can build upon and get newer functions, making a proper self-driving car. So comparing the two, comparing a self-driving car and a human-driven car. For perception, the self-driving car has a camera, a lidar, and a radar, while the human-driven car has its eyes and ears. That's for the perception part. Now, for computing, how will the car compute, or who will be doing the computing for this car? For a self-driving car, it is a computer built inside the car. For the human-driven car, it's obviously controlled by the brain. Now, the self-driving car, for its controls, who is going to control the car? The electronics built inside, along with the computer, are going to do the self-driving for the car. And for the human-driven car, that would be the hands and the feet. Now, I'm going to talk about everything you saw on the car, on the self-driving car, or the previous model, or the definite models. So let's first talk about the cloud. What is everything stored? It's going to be stored in the cloud. All the maps, all the algorithms, all the processing, all of that is stored in the cloud. And that is where the car will access that. So the cloud must also have Wi-Fi. And with that, the car can access all of that, and it will have all the knowledge, as it cannot store all of that in the car. So the components of a self-driving car. I'm not going to go over all these components, but I'm going to talk about the main ones. You have the radar and the lidar. The lidar uses light beams to help determine distances between obstacles and sensors, while you have a radar, which helps determine radio waves between. Instead of light beams, it uses radio waves to determine the distance between obstacles and the sensors. You also have your ultrasonic sensors and your infrared sensors. These are used to basically sense anything that is on the side of the road or any lane markings. You can also sense bicycles, pedestrians, road lines, even parking assistance. Anything that needs to do, the sensors will be there for it, so it can sense where it should be properly positioned. As previously discussed, the cloud saves the GPS and the pre-built maps. That is all saved in the clouds. You also have your INS, which is the inertial navigation system, which is used to help basically improve the accuracy of the GPS. And then you also have some cameras. Those are basically used to help percept everything so the sensors can do their job properly. Now, if you would like to read this, this can be easily seen later on. Now, since I've talked about everything about self-driving cars, here you're going to see a few examples, and hopefully you can notice some of the things that I've talked about. For example, on this Google self-driving car, you can see the lidar on the top of the car, and then the sensors surrounding the car right here, and right here. This is the lidar. Another example is this Uber self-driving car. And instead of seeing everything attached on the side of the car, it is all attached on the trunk, or sorry, my bad, the roof of the car. As you can see, there is the lidar on the top, and all the sensors and cameras are on top of the car. This is another example of what a self-driving car is by Uber. As you can see, there is the lidar, which is right here. Then you have your cameras, again, right here, and then more cameras and an antenna, which is included this time. Now, the lidar uses multiple different beams, which can be 1.4 million lasers per second, which is used to help basically create a map surrounding the car. And then, of course, you have a cooling system to make sure the car doesn't overheat, like your computers, which have software, AI, and all of that built in. A car also must have that. And then you also have some lidar molecules to help basically detect obstacles, which are like sensors. So behind the scene, how does this all work? So you, of course, have your object detection, which is used to detect objects like sensors. You have object identification or recognition, which is object classification, which is used by cameras mostly to help detect objects so the sensors of the car and do better. And then you have object localization and prediction of movement. This is also done by LiDAR and radar to help predict the movement. Now that I've talked about self-driving cars, I'm going to talk about the COVID-19 situation. These are, just before I get started on that, these are also some of the basic things. I can give you a minute to quickly read this if you would like.
Yeah, so I can add here that, as you look at lots of data, like in the example, 1.4 million points being processed with 20 cameras, you can imagine a car has to decide if somebody is coming in, whether it should stop or whether it should go. When it sees a stop sign, what should it do? When it sees a human, what should it do? And when it sees a curb, like to turn right or left, what should it do? It has to decide all that in real time. There is not like you can wait for 30 seconds to make your decision. So all that is getting processed here with the amount of data that it has collected, and it is building that intelligence over time. So if it has been given 1 billion data points already, it has processed that, and it has now a knowledge that this is a red light, this is a green light, and now I must go forward. And so, yeah, so these are some of the algorithms that are generally used, like, whether you want to, how you want to classify the object, whether it's a dog, a cat, a human being. Sometimes the object is not very clear. So how do you group them into clustering, and how do you make quick decisions, whether the car needs to take a left turn or it needs to take a break? So as you read about this, there are different algorithms that one can go through and figure out. So maybe we need to stop the share once, because there is some annotation by some attendees. So just stop the share once and reshare. So now go ahead.
Okay, so let's go back to the COVID-19 situation, which is a current real world problem as it is a pandemic. So how do you think machine learning, you might think, is not really used in something like this? Well, that is completely wrong. Machine learning is very much used in something like this. Blue Dot, which is a company, uses real, almost near real-time data to help predict where the virus might spread or pop up. This is used to help predict where the coronavirus might appear, so that officials or doctors or healthcare providers, they can take the action needed to prevent this from occurring. So how do they do that? They look at social distancing. Are people meeting up? Are, like, even small groups of people, are they meeting up? Are they doing things? Blue Dot looks at all of that. They look at, are people staying clean? If people are, probably being clean, are the cities clean? They look at all of that. They gather all that data. Again, they check if people are gathering in large groups this time, like if there are events going on or people are meeting in large groups to go somewhere. They check to see all of that. And a big thing they check right now would be how many people are traveling regularly. So they want to make sure that not many people are traveling on a regular basis. So these are what Blue Dot checks, and this is all used in near real time to make sure the virus or something like this does not spread over time. So this is a city in the United States of America called Chicago. Some of you might have heard of it. In this data set or point or graph, whatever you want to call this, as you can see, the blue part is the part where people are staying clean, social distancing, and doing the best to avoid the virus. This can be seen right here and right here too. And they're using cell phone data to be able to do this. And then the orange part The orange is where people are not following social distancing protocols and people are meeting up in large groups and not staying properly clean. And this can be seen in these parts, this part, and this parts. All these parts show that where coronavirus or the COVID-19 might pop up. Here is another city in the United States of America, a very popular city, Los Angeles. You can see wherever the larger dots are or wherever more dot points are, even the red points, that is where the corona or the COVID-19 will be greater. As you can see in the main city, there are many dots and points, and here are the red points. And as you can see around here, this is blank, meaning that people are keeping fine and the virus is not most likely going to be there. They use cell phone data to track all of this. So the government uses all of this to help prevent. As you can see, this is what the government basically would see. They see where the corona or the COVID-19 situation would be. As you can see, wherever the red dots or the blue dots or the yellow dots are, that is where the virus is most frequent or most popular. And this would be for the city of California. Now that I've talked about the virus and self-driving cars, what can we expect for the future? So for the future, we can definitely expect robots, self-driving cars, more AI, a lot, and I repeat, a lot of robots. We can definitely expect all of that, especially robots doing basic technique or job that would require someone to be paid, like delivering packages, maybe even making food or something along the lines of that. So I would definitely say that you should definitely be excited for the future, as there's so much in store for us to see and for us to even be part of, so that we can be a part of this next future, so we can bring to the table and all of this type of stuff. So hopefully you guys found this presentation, you found it interesting at least. So, but that will be all. Thank you.
All right. I think how we're doing on time. I think we're doing good. Okay. So yeah, so we can open it up for Q&A at this point. If there is something specific that you would be interested in hearing about, or learning about, or wanting to know more about anything in particular, whether it's how the car works, or whether how the cybersecurity, we'll be open to taking questions at this point.
Thank you so very much, Mr. Saurabh and Shreyas, for this interesting and wonderful presentation. Definitely, participants must have learned about many things related to online security, and Shreyas has talked about the self-driving cars. That's really an interesting concept, and as he mentioned that in future you never know, you will be coming up with so many different things. There is so much in the box using
Right,
this
right,
AI.
right.
Yeah.
Yes, very true.
So thank you so very much for your presentation. Now I would like to invite our director, sir, Dr. Saurabh Gupta, Director of Geeta Group of Institutions. Sir, can we have you?
Yeah, Deepika, very good morning.
Very good morning, sir.
My voice is clear?
Yes,
Yes,
sir.
we can hear you.
Okay, Mr. Jain, Mr. Saurabh Jain, thanks a lot for wonderful presentation. As far as Shreya, I saw, I'm watching him as a young, young entrepreneur. He is going to be young entrepreneur. It's very good. At the outset, it's my proud privilege to be on such a great platform where, like Shreyas, is I would like to say that he was talking like an expert.
Thank
In
you.
fact, Mr. Saurabh Jain, we are really thankful to you for sharing this wonderful information to our audience and to our whosoever is attending this webinar. In fact, Mr. Ankush, who is our vice chairman, he was supposed to join, but somehow I think he's busy somewhere. Otherwise, he's always very curious to join all these types of seminars, and he was very curious about this particular seminar. He was in touch with me for last 2 3 days, and he was insisting, sir, Mr. Saurabh Jain is going to be present this webinar. Along with him, Mr. Shreyas will be there. So, but anyhow, in his absence, it's my duty to propose a very vote of thanks to you, Mr. Saurabh. This was really a nice presentation. Because the topic what we have chosen for this particular webinar that belongs to data science, artificial intelligence, and machine learning.
Right.
Whatsoever we talk about these topics, these are very hot topics nowadays. Latest
Right.
topic because we are we are talking on the latest technologies. Because
Right.
you have very well said that if we talk about the technologies, we are, I think, in the fourth revolution. And
Right.
that's why Industry 4.0 concept is nowadays is very much popular. And
Right.
many of the people might be not be aware about this. Everywhere posters are there that we are moving towards Industry 4.0. What is this Industry 4.0, or you can say 4.0?
Right.
Because this is a general topic. If we talk about this industrial revolution, this is, I already said, this is the fourth revolution, and we started the first revolution when the steam engine was in picture, and during 1780s or 1800, that was the first generation. Then the second revolution came up around 1870 and 1900, when the rail network, road network, telegraph network, electrification, and a lot of economic growth that have been taken place. So that was the second revolution. And after the end of the Second World War, that after 1950, and if we talk about the late 90s, the third revolution start, and that was a totally digital revolution, in which we also, this internet was there, 3G, 2G was there. And in fact, in the last 3 to 4 years, the fourth revolution comes into the picture, that we say that it is Industry 4.0, where we are watching that everything is digitalized, everything is computerized, everything is technology based. How we walk, how we talk, and so Shreyas are already very well explained the concept of driverless car. So I think we should say thank to the technology, because whatever technology, if we talk about the in this particular education field, what observation do we have in the last 3 to 4 months that was really marvelous? Because Ratan Tata ji has already said that what we have not seen in last 50 years, that we have seen during the last 3 to 4 months, that the revolution, and that is technology revolution. If we talk about the digital technologies, and you talk anything, smart sensors are there, uh, latest advanced robotics is there. Then we are working a lot on big data analytics. So this is a very
Yes.
latest topic. Then if we talk about 3D printing, that is the latest concept. Then AR, VR, that is augmented reality, and VR, virtual reality, very, very hot topic nowadays.
Right.
Everybody knows about cloud computing. We are moving everywhere. We can be located, means our location can be detected. Internet of Things,
Right.
simulation, 5D technologies. I means everywhere. This is
Right.
IoT, and I think digital technologies are there. So I
Right.
think this is a very vast topic, and we can have so much debate on these topics. So
Right.
basic purpose of arranging these seminars, or nowadays it is called webinar, because we are connecting each other
Yes.
through web.
That's good.
And once again, thanks to the technology, because in the older times when I started my career 23 years back, we used to
Right.
move other countries or other states for just attending this type of seminar for just sharing their views. But now
Right.
it is a platform. You are here, you are there in US and talking to us, and nobody can say that you are in US and I'm in India.
Right.
That doesn't make any difference. So this is
Yes.
all credit goes to technology, and I
Yes.
think if you talk about the technology, technology was there in older times. Even when we talk about Mahabharata, we talk about Ramayana, technology was also there, and
Right.
that was really marvelous technology. So
Mhm,
I think
mhm.
technology is never going to be end. It is ever demanding, and it will be never, I think, less in demand. It will be ever growing. So this was the basic purpose of arranging this webinar. So once again, Saurabh we are so grateful to you for sparing your valuable time, and dear Shreyas, so grateful to you also, because I'm looking you for a very good entrepreneur in near future.
And
So, I'll convey to Mr. Ankush Bansal also. So once again, we are thankful and thankful to Dr. Amit, who is always supportive for arranging these all types of webinars, because Mr. Amit is looking as a Dean Researcher of Development of this institute, and he's constantly working on arranging these types of seminar. I think Mr. Jan, if we talk about him during last 2 3 months, we approximately he has arranged, I think, approximately 50 webinars
Wow, that's
and
awesome.
topics. So that
Awesome.
that is our intention, that we are doing our level best, and this is only due to the hard work of Dr. Amit. So I'm thankful to him also. Thankful to Deepika, who is always making these webinars, because if we talk about the role of this, you can say
Right.
moderator is a very important
Right. Right.
term, very important
Right.
aspect, because he has
Yes.
to moderate all the things. So
Right.
he is totally dedicated to her duties. So I'm thankful to her also. So once again, I'm thankful to all, each and every participant of this particular webinar, and specifically once again to Mr. Saurabh Jain and Shreyas. Thank you so much.
Thanks a lot. Thanks a lot. Thanks a lot for your very, very nice and kind and very, very generous word, Dr. Saurabh Gupta ji. We are truly honored by those nice and kind words. We would also like to echo, Deepika has been constantly, it takes a lot of effort to arrange a session like this and a lot of coordination. So we'd totally like to appreciate and applaud Deepika as well as Dr. Amit for being the behind the scene in being the push and making this happen. And I said this in the beginning, I've been in touch with Shri Ankush ji also. He's definitely a forward thinking leader, and as you rightly put, right, every industry is being impacted by technology, in some fashion or the other, right, generally in a very big way. And that's what I really like about Shri Ankush ji, about really thinking forward, looking from a Gita Engineering, college and the whole institution, really thinking about future thinking, bringing in new technologies, preparing the leaders, if you will, so that you have the right foundation, the right basis on which you can build your career. So with those, I would like to definitely thank you from, on my behalf and Shreyas's behalf for giving us this opportunity, and we'll stay in touch and looking forward to further more of these.
Sure, sure, Mr. Jan. So nice of you. Thank you very much.
Thanks a lot.
Over to Deepika.
Yeah, thank you so very much, sir, for appreciating the efforts. And I again extend my hearty vote of thanks and deep sense of appreciation to Shreyas and Saurabh for joining us today. And really, it was a very nice presentation. And definitely, participants must look forward for the upcoming technologies also, and for the another presentation also. Well, thank you so very much to all the participants for joining us today. And I would now like to take up if I have any queries. For any queries, I have already shared the contact number in the chat box. If people want to connect to us, they can have the number from the chat box and connect to us in the future also. Thank you so very much for all for your participation in this session. Thank you all. Stay safe, stay home. Thank you.
Thank you. Bye.
Thank you very much. Thank you.